All right. So this is demo one. We're going to do a demo of just basic simple cylinder objects. Then we're going to do a demo of a cube. And then we're going to talk about more complex forms. At the end of this demo, I'm going to also just kind of show you some of the previous demo drawings. So the first step is to get, anytime you're looking at any kind of cylindrical object, is to get a measurement of the height. In this case, it's the height of the whole stack. Not just one form, but of both forms. I'm now kind of dividing that up, and I'm getting a measurement for the sides. So far, this is all just in Vine. And so having a center line down the middle, A, gives me a chance to measure the height of the form, but also allows me to be thinking right from the start about keeping everything symmetrical, which will come into play, especially when we talk about bottle forms, where they have necks that are curving, and the curves of both sides of the neck need to stay symmetrical to each other. Since we have time, I'm going to make sure that I have all of my verticals as straight and as vertical as possible. So I'm going to check them by looking at them both sideways and upside down, just to make sure that I'm not making any obvious drawing errors. Okay, so next step is for us to start thinking about the ellipses for each of the levels. So remember that when we're drawing an ellipse, right, that it is like a circle, but not a circle. It is like an oval, but it is not an oval. It's like a circle in that it's a continuous curve, unlike an oval. So it has no points where it flattens out. But unlike a circle, it is not a constant even curvature. It doesn't curve at the same rate all the way around. In fact, it slows down and then it speeds up as it goes. Right? And so an ellipse is the form that we see when we're looking at any circular shape on any plane and at any angle to our eye. So the first ellipse that I'm going to draw is I'm going to draw the middle one, the top of the lower cylinder. So how do we know what is an accurate measurement? Well, we can measure that ellipse in relation to like the height of the form. And so in my measurements, I got that this ellipse was essentially about a little bit more than half, like somewhere between half and 2/3 of the height of the whole cylinder. So remember the principle that as we get closer to our eye level, so higher up, these ellipses will get more narrow, meaning that this distance will get less compared to the width of the ellipse. This bottom ellipse here is going to be proportionally exactly the same as this ellipse. That's the top. So the top ellipse of the can that this cylinder tin is sitting on top of, the top ellipse of this and the bottom ellipse of that are, because they are lying directly on each other, are pretty much going to be the exact same ellipse, just smaller. But what I mean by exactly the same is that the proportion between this to the width will be the same as the proportion of this to that width. Whereas the bottom ellipse one thing we know for certain about this bottom ellipse is that it has to be at least a little bit more open than this. It definitely cannot be less open because it's further below our eye level. It is also true that frequently when we look at cylindrical objects, there are, for various reasons, we might believe that we're seeing, we might be seeing a flatter ellipse at the bottom than in the middle. Now, looking at this, feeling like I've made this height a little bit too much, so I'm going to bring that bottom ellipse up. And so one of the reasons why we always draw our ellipses transparently, meaning that I will draw the ellipse going back to the back of that cylinder, even though I can't see that, is to help us make sure that we are definitely drawing this one just slightly more open than that one, rather than the other way around, drawing it slightly less open, which is what we're tempted to do. So far I'm drawing entirely in vine. Not sure if I said that already. And then we're left with the top ellipse. Which I'm going to get to. At this point, I'm probably going to switch black Conte. Before I do that, though, I want to be certain about my measurement for this height. I'm going to recheck that. So pay attention to the fact, one of the things I hope you're seeing from this is that everything is checked and rechecked, that I'm not assuming that I am right at any point, that I consider the possibility that I'm wrong at every step. That's pretty important. That is fundamental to drawing. The reason why drawing is hard is because we all assume that we can see. It is kind of an assumption to life that we all can see relatively accurately. But unfortunately, as drawing teaches us, none of us see accurately, and it requires training and practice to learn to actually see accurately. To actually be able to look at a cylinder and really measure its proportions accurately, to really know how much more narrow this ellipse is from that one, or even to just be getting close. One of the things you might notice is that, and we've talked about this when we were talking about cross-contour lines, right? How cross-contour lines should, most of the time, the rule should be, with some exceptions, but the rule should be that they curve up to the contour line and right into the contour line. And you notice that when you're drawing these ellipses and you draw them transparently, so they're already curving around, that happens automatically, that your ellipses are going to curve into and wrap up to your contour line. Now this lid for the bottom tin is pretty complex. I'm not necessarily going to replicate it exactly as complex as it is, mostly because we don't have a lot of time for these demos. And that level of specificity is less important than learning to see your ellipses accurately. Okay, and also, as a general rule, I want to emphasize, draw everything transparently and don't, as much as possible, don't erase all of your measurements and all of your mistakes. Notice I haven't erased those lines. I want to see, when we're working on this type of drawing, these kind of very Euclidean-based drawings, I want to see all your decisions, how you got there. It's kind of like in math, showing your work, right? I want to see how you got there. And the fact that you measured one thing one way and then readjusted it, that's a good sign. It's a very good sign, to quote a song. So, in the remaining time for this video is almost over because we're about to do the demo on the cube form, but I want to show you some previous demos. Remember, these folios stay in the classroom for you to look at. Some are better than others, some are real quick. Notice how off I was on that, or even on that. We're going to be talking about cubes in a second. The rest is all cubes. Hold on, there's one more folio I want to show. And then this one has a lot of more complex forms, like that one and that one. I'll be trying to do, this is a narrow bleach bottle, a little bit wide here at the bottom. Another one of those no ends, another cube style. And I include both the kind of like really fleshed out, but also the real quick ones, so that you can kind of see how you get from here to there, how the steps develop. If I only had folios of just perfect demo drawings, well, A, I'd have a lot fewer demo drawings, and B, it would be less clear to you how we get from one stage to the next. Okay, that's the end of this video. Thank you.